Hello everyone, my name is Jaehoon Hwang and I'll begin my Capstone Design final presentation. The topic is Finstructor, a combination of finance and instructor. It is a finance Q&A chatbot web app. The motivation behind starting this project can be divided into two categories. Personal motivation was driven by the desire to experience the entire process of model surfing firsthand. I wanted to gain experience designing and implementing everything from infrastructure to the back end and front end. A chatbot web app was deemed to the most suitable project to showcase this end-to-end process. Social motivation stems from addressing the issue of financial illiteracy. Through the related news, I learned that many young adults fall victim to financial fraud due to lack of their financial knowledge. I believe that creating a chatbot capable of explaining financial terms and situations could help solve these problems. For example, when explaining the term opportunity cost, the Wikipedia definition is clear and concise. However, it may be difficult to understand for someone unfamiliar with financial concepts. On the other hand, using the example like a middle school student managing their allowance within a limited budget explains the concept in a more relatable and everyday manner. Through this approach, I aim to make the concept more accessible. So, what makes a response accessible? I made three key criteria. First one, it must be clear and concise, and it should be minimize the use of technical jargon. Thirdly, it should explain concepts using everyday examples. The service consists of three main pages. User authentication page provides basic features such as login, sign up, profile updates, and account deletion. Chat page supports managing chat sessions and interacting with a chatbot. Vector management page allows users to research, add, edit, and delete documents used in the REC process. For making response, first, when a user input is received, the system determines whether the user's question is related to financial accounting. If the question is unrelated and more of a general, everyday query, a vanilla prompt without financial context is used to generate the response. On the other hand, if the question is related to financial or accounting, the system creates a question embedding, retrieves five relevant documents from the vector store, and generates the answer using the rec prompt. The service was designed using a microservice architecture. The generation-related functionalities were separated from the web app and implemented with Fast API to improve efficiency through asynchronous processing. Django, being synchronous, was inefficient for serving GPU-based models. To address this, Fast API and Redis were utilized to quickly fetch chat data, while Postgres' pgvector was used as vector store. Authentication and authorization were also key considerations. While Django's default authentication system supports session-based login and CSRF tokens, FastAPI does not. To address this, middleware was added to issue and validate CSRF token in FastAPI. Additionally, Django REST Framework's simple JWT was used to issue JSON Web Tokens upon login, which were then validated in FastAPI. This approach allowed for a unified authentication system between Django and FastAPI. For deployment, AWS services such as ECR and ECS were utilized in conjunction with Docker Compose, and an instance with 16 GB of VRAM was used. The database structure is as follows. You can see that a significant amount of data is shared between the Django and FastAPI apps. The project was carried out over approximately 7 weeks, from October to mid-November, following the GitHub Flow methodology. During the model selection process, multiple models were compared and tested. 4 candidate models were selected and 3 comparative experiments were conducted. Additionally, 4 variations of the RAG approach were used, with the evaluation criteria as follows. First one, accuracy and relevance of responses, and generation time, and RAGAS score. The experiment involved selecting 7 questions at random, and generating ground truth answers using GPT. For each question, responses were generated 10 times per rec type and model. The scores were then averaged to evaluate performance. As a result, a smaller base size model outperformed a quantized larger model, and prompts tailored to specific situations significantly improved the reg performance. It is essential to carefully choose the appropriate approach, balancing the trade off between generation time and performance. A demo video of the service has been uploaded on the YouTube. Please feel free to watch if you're interested. This project has become an essential part of my portfolio. Through it, I learned how to design efficient and scalable services while overcoming technical constraints. However, due to the budget limitations, I was only able to secure 16 gigabytes of free RAM. This required designing the system to operate with a single model instance using mutex locks and semaphores. The number of concurrent requests was limited, and additional requests were met with the HTTP 423 error. If more resources had been available, I could have provided a faster and smoother user experience. Thank you for listening my presentation.